Hello there, Mr. Sutton bringing you the Chapter 5 AB Calculus Quiz 1 review solutions on antiderivatives. To find the antiderivative of this polynomial, we're going to use the reverse power rule term by term. So for the first term, this exponent bumps up to a 6. Dividing by 6, we have negative 2x to the 6th. Then for this next one, this becomes an exponent of 3. Dividing by the new exponent 3, we have negative 4x to the 3rd. And don't forget the plus c. To find the antiderivative of this polynomial, we're going to use our reverse power rule term by term. So for the first one, this bumps up to an exponent of 4. Dividing by 4, we have 2x to the 4th. For the next one, this new exponent's going to become 2. 1 plus 1 is 2. Dividing by 2, we have negative 4x to the 2nd. And then this 3, using our reverse power rule again, this just gets a coefficient, or this is just a coefficient on 3x. And then don't forget the plus c. To find the antiderivative of this radical function, we're going to convert this into a fractional exponent. So this is really 7x to the 2/5. And now I'm going to use my reverse power rule on this. So if I add 1 to 2/5, that becomes 7/5. So I'm going to have 7x to the 7/5, but I have to divide now by that new exponent. If I'm dividing by 7/5, I'm really multiplying by the reciprocal of 5/7, and don't forget the constant over there. If you wanted to simplify this, these 7's cancel, leaving us with 5x to the 7/5 plus c. In order to take the antiderivative of these simple rational functions, we're going to convert these into negative exponents. So I'll rewrite this as negative 5x to the negative 2 minus 8x to the negative 3rd. Now going term by term, we're going to use our reverse power rule. This first exponent, if we add 1, that becomes an exponent of negative 1. Dividing by negative 1, we have positive 5x to the negative 1. Next, this exponent bumps up to a negative 2. Dividing by negative 2, we have 4x to the negative 2 plus a constant. Taking the antiderivative of this trig term, the antiderivative of sine by itself is negative cosine, so then this will be negative 4 cosine of x plus c. On this problem, the antiderivative of secant squared by itself is tan of x, so then this will be negative 2 tan of x plus c. For this problem, the antiderivative of secant x tan of x is just secant of x, so with this 2 out in front, we have 2 secant of x plus a constant. To take the antiderivative of this function here, it's easier if you think of this as being just negative 5 times 1 over x. The antiderivative of 1 over x is ln of absolute value of x, so then this will be negative 5 ln of absolute value of x plus a constant. On this one, the antiderivative of e to the x is also e to the x because it's its own derivative. So then we have 2e to the x plus a constant. For this problem, to avoid having to deal with a product, we're going to distribute this 3x squared to this parentheses, so simplifying this. So that'll end up giving us 15x to the 4th plus 9x squared. And now we're going to go term by term and use our reverse power rule. So this first exponent bumps up to a 5. 15 over 5 gives us 3x to the 5th. For the next one, our new exponent's going to be a 3. 9 over 3 is going to give us 3x to the 3rd. And don't forget your plus c. To make our lives a little bit easier on this one, we're going to divide both of these terms by x to the 5th. Alternatively, you could bump this upstairs as x to the negative 5th and distribute it. Either way, you're going to end up with 3x to the negative 4th minus 4x to the negative 5th. And now I'm just going to go term by term using my reverse power rule. So this exponent here bumps up to a negative 3. Dividing by that, we have negative 1x to the negative 3rd. Over here, this bumps up to a negative 4. Negative 4 over itself is just going to be plus 1x to the negative 4th and plus a constant. For this problem, in order to take the antiderivative, we're going to try to simplify this before we use any other techniques. So I see here that the numerator looks factorable. Two things that multiply to negative 7 and add up to negative 6. That would be x plus 1 and x minus 7. And now that I've split that up, I can cancel out these x plus 1s. So I'm really just taking the antiderivative of x minus 7. So that's going to end up being, if we use our reverse power rule, this will be, let's see, this bumps up to a 2 for the power. Dividing by that, we have 1/2 x to the second. And then using our reverse linear rule here, this is just going to be negative 7x, because the derivative of 7x is 7. And don't forget your constant. For this crazy-looking function with a square root with a polynomial inside, we're going to see if we can break this polynomial down at all. Our only hope is if it ends up being a perfect square. So let's see, two things that multiply to 9 and add up to negative 6. Well, negative 3 and negative 3. So this is x minus 3 squared. That means I can cancel out the square root with the square, and this is really just 1 over x minus 3. This is just a special case of 1 over x, so we're going to use our ln antiderivative rule. This is just going to be ln of absolute value of x minus 3 plus c. The trick on this particular problem is to convert this into a trig function that we're more comfortable taking an antiderivative of. So I noticed that I've got 4 over secant of x. Well, the reciprocal of secant is cosine, so I could really write this as negative 4 cosine of x dx. And once I've written it like that, antiderivative of cosine is sine, so then this is negative 4 sine of x plus c. To make sense of this trig function inside a fraction, I'm going to try to get rid of this fraction by using the reciprocal function. The reciprocal of cosine is secant, so then I can write this as 4 secant squared of x dx. And then the antiderivative of secant squared is tan of x. With this 4 out in front, that becomes 4 tan of x plus a constant. For this problem, I've got this fraction with multiple trig functions in it. So I'm going to see if I can simplify this to something that's easier to take the antiderivative of before I do anything else. So I'm going to split this up, actually. I'm going to split this up into 1 over cosine of x times sine over cosine. And you'll see if we were to multiply this back together, we would get what we started with. So the reason I did this is because each of these can be simplified to another trig function. 1 over cosine is really secant. Sine over cosine is tangent. So I really have secant x tan x, and I know that the antiderivative of this is just secant of x plus a constant. For this problem, I have to be mindful of the 8x inside the sine function. Now, the antiderivative of sine is cosine, or actually negative cosine. This negative out in front makes it a positive cosine of 8x. But then, since I have a linear inner function, I have to take the derivative of that and divide by its derivative. So I'm really dividing cosine of 8x by this 8 in here. So when the dust settles, I have 1 over 8 cosine of 8x plus a constant. On this problem, I'm trying to find the antiderivative of 4 cosecant 16x cotan x dx. So for this one, since I have this inner linear function of 16x, I'm going to have to divide by the derivative of that, whatever my antiderivative ends up being. I'm going to be basically multiplying by a 1 over 16, so just know that going into this one. But now our overall rule here we have to use is the cosecant of something, cotan of something antiderivative. That is going to be, let's see here, we're going to have a negative cosecant, negative 4 cosecant of 16x. And then we have to multiply by that inner tail of 1 over 16. Don't forget the plus c. And if we want to simplify, we can make this negative 1/4 cosecant of 16x plus c. To find this antiderivative, since I have secant squared of something, the antiderivative is going to be tan of something. I have a 5 out in front, so I could write 5 tan of 5x, except that my inner function is a linear function with a coefficient other than 1, so I'm going to have to divide by the tail there. I'm basically multiplying by 1/5. And then I have a plus c that I don't want to forget about, so I'll write it now. So if you want to simplify this, the 5 and the 1/5 cancel. This is just going to be tan of 5x plus c. To find this antiderivative, I'm going to treat this as kind of a 1 over x situation, except that my function down here is a linear function that has a coefficient other than 1. So I'm going to have to end up dividing by a 3 when all is said and done. So to take this, I'm basically going to have 4 ln absolute value of 3x minus 9. But again, then I have to divide by that inner derivative. So that's 1/3 that I'm multiplying by. I'll put a plus c here so I don't forget anything. And if you want to simplify, we've got 4/3 ln of 3x minus 9 in absolute value plus c. To take this antiderivative, I know that the antiderivative of e to the something is essentially e to the something, but there's a little bit more going on inside the exponent here, so I'll have to be mindful of that. But I'm going to start by writing 2e to the negative 1/3 x. But now, since my inner function is a linear function with a coefficient other than 1, I'm going to have to divide by the derivative of this linear inner function. So if I'm dividing by negative 1/3, I'm really multiplying by negative 3, the reciprocal of that. And I have a plus c that I have to be mindful of. And if I want to simplify all this, this is just negative 6e to the negative 1/3 x plus c. For this problem, I notice that I have something that looks kind of similar to 1 over the square root of 1 minus x squared, and the antiderivative of that form would be arc sine, but I have a 16 instead of a 1. So in order to take the antiderivative of this, I need to turn this into the form of square root of 1 minus something x squared. So to do this, I'm just going to factor a 16 out of 16 and negative x squared. When I do that, I have 1 minus 1/16 x squared, which is kind of weird to factor a 16 out of something that just has a coefficient of 1, but this is going to end up working, so that's why we do it. So just simplifying and cleaning up a little bit, if I have a 16 being multiplied by stuff inside a square root, I can split that off into its own square root and actually square root it. So this is really 1/4 that I can bring outside my integral. And inside here, I'm going to convert this 1 over 16 x squared into a 1/4 x quantity squared. So I brought out my 1/4 from this 16 that was here. And again, this 1 over 16 x squared, I'm now writing that as 1/4 x, the whole thing squared. And the reason I'm doing this again, I want to have that form where I have 1 minus something squared. So now that I have this, I can take the antiderivative of this. This is going to be 1/4 arc sine of 1/4 x. But since I'm taking the antiderivative of something with an inner linear function that does not have a coefficient of 1, I'm going to have to divide by the tail of this inner linear function. So dividing by 1/4 is really like multiplying by 4. And don't forget the plus c out there. And if you want to simplify this, the 1/4 and the 4 cancel. So this is just arc sine of 1/4 x plus c. For this problem, I noticed that I have an x squared and another constant downstairs. That's usually a pretty good indication that you have some kind of arctan antiderivative you need to take. But it doesn't work with x squared plus anything other than 1. This number here needs to be a 1 in order for this to work. So in order to get that, I'm actually going to factor a 9 out of my denominator. So I'm going to write this as 9, and I'm going to switch these around. So I'm going to have 1 plus 1/9 x squared. So I'm going to bring the 12 and the 9 outside here. Or actually, I don't know, I'll just bring out a 9. And then inside, I'm going to rewrite this as 1/3 x quantity squared. So there we go. This is looking a little bit more arctan-y. Now I'm going to take the antiderivative. So I'm going to write this as, let's see, we're going to have a 12 over a 9 arctan of 1/3 x. And even after you've done all that juggling of coefficients, since you are taking the antiderivative of something with a linear inner function, you have to take the derivative of that and divide by the derivative. And since it's not just a coefficient of 1, that means it's going to affect things. So dividing by the 1/3, we're really multiplying by 3. Don't forget the plus c at this point. And then 3 and 12 over 9, well, that's really going to be 36 over 9, which is just 4. So when the dust settles, we have 4 arctan of 1/3 x plus c.